Littleton Coin Company is ringing in the holiday season with daily deals. Visit littletoncoin.com for at least 15% off select products now through November 28th. Save on your favorite coins, such as Morgan Silver Dollars, Kennedy Half Dollars, commemorative quarters, and much more. But hurry, each day offers a new deal you don't want to miss. Visit us now at littletoncoin.com. That's littletoncoin.com. Littleton Coin Company, serving collectors since 1945.
This is SpaceTime Series 25, Episode 70, for broadcast on the 27th of June, 2022. Coming up on SpaceTime, astronomers discover a monster black hole consuming as much mass as the Earth every second. Discovery of a possible new fundamental particle. Could it be dark matter? And NASA says it's finally ready to launch its giant new Artemis 1 SLS moon rocket. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered a supermassive black hole that's consuming as much mass as the planet Earth every second. The newly found object, with a romantic name of SMSS J11447.77 minus 430.859.3, is located some 9 billion light years away and has some 2.6 billion times the mass of our Sun. The discovery, reported in the publications of the Astronomical Society of Australia and on the pre-press physics website archive.org, is generating the most luminous quasar known over the last 9 billion years of cosmic history and shining some 7,000 times as bright as the light from all the stars in our Milky Way galaxy. So, despite being so far away, it's bright enough to be seen with backyard telescopes. Quasars are powerful beams of energy and matter generated by feeding supermassive black holes millions to billions of times the mass of the Sun. Material falling onto an accretion disk surrounding these monster black holes is stretched, crushed, and torn apart at the subatomic level by immense gravitational forces and through friction caused by collisions with other material on the disk. While most of the material on the accretion disk is doomed to eventually pass a point of no return called the event horizon and fall forever into the black hole singularity, some of the superheated matter is deflected by magnetic fields before reaching the event horizon and is instead channeled into powerful beams jetting out perpendicular to the accretion disk at close to the speed of light, shining as incredibly bright beacons visible on the other side of the universe. The study's lead author, Christopher Onken from the Australian National University, describes the discovery as the fastest growing black hole in the last 9 billion years. The discovery was made when Onken and colleagues performed a spectroscopic investigation of what looked like a bright blue point-like source spotted in the SkyMapper's Southern Survey Project's second data release during a search for symbiotic binary star systems. Onken says astronomers have been hunting for objects like this for more than 50 years. They've found thousands of fainter ones, but this astonishingly bright one had slipped through unnoticed until now. Now astronomers want to know why this one's so different and whether something catastrophic happened. Perhaps two big galaxies have merged together, funneling a whole lot of material onto the black hole to feed it.
There was a student making use of our survey that we've been conducting over the past few years with the SkyMapper telescope, which is cataloging as many sources as we can see in the southern sky. And the student was looking for pairs of close binary stars where they're so close they're actually transferring a bit of atmosphere from one star to the other. But one of the 200 candidates that they found and were following up in more detail turned out to be something completely different from a pair of stars. Turned out to be black hole growing at a very rapid rate, more or less halfway across the universe.
Now, when you say growing at a rapid rate, how big was this thing?
So we didn't know at first how fast it was growing or how massive the black hole was. So we had to acquire some additional data, spectra from telescopes in Chile and from here in Australia. And what that showed was that the black hole has a mass of about 2.6 billion solar masses and is growing at a rate of about 80 solar masses per year, which works out to about an Earth mass every second.
Now, you say growing, that means that must be a fair bit of energy X-ray coming from that thing right now.
In fact, it's the most luminous growing supermassive black hole that we know of in the last 9 billion years of cosmic history.
What part of the sky is it in?
It's in the constellation Centaurus, which is easily observable from the southern hemisphere here, a bit harder if you go to the north.
And you use SkyMapper to find it. SkyMapper is part of the Exciting Spring Observatory?
That's right.
How far back in space-time is this object?
So the light's been traveling to us for about 7 billion years.
Literally halfway back, wow.
Yeah, and you have to go back to about 9 billion years before you find any black holes growing as rapidly as this one. And further back, you see many that are growing this fast. That was a time when the universe was much denser. It hadn't expanded as much, and there were many more galaxy collisions going on that we think can help feed these black holes with a lot of material for them to grow with. So this is quite an unusual outlier. It's much brighter, growing much more rapidly than any others at the epoch of the universe at which we see it. The best analogies we may be able to draw will be between this object, which being closer we can study in a bit more detail, and the black holes that were growing in the very early universe. We see some black holes within the first billion years since the Big Bang have grown up to be a billion times the mass of the sun. And it's not a process we understand very well. And so this may be a bit of a clue as to what that growth process is like, and in turn, how massive the seeds of the black holes in the early universe must have been, whether you can grow them from just large stars or if you need some other process that can grow them to much larger masses even more rapidly. We know that it's a very massive black hole with 2.6 billion solar masses, so it's already done a lot of growing in its past, and what makes it so bright compared to its contemporaries is not clear. We hope we can study it in a bit more detail to figure out whether it's in a galaxy that's had a recent collision, or to figure out perhaps if it's growing, if there's something about the black hole itself that allows it to shine much more rapidly. Black holes can have a spin, an intrinsic spin to them, and a rapidly spinning black hole can give off much more light from the material it's secreting than a black hole that's not spinning.
Have you been able to work out its Schwarzschild radius?
If it's a typical black hole, the Schwarzschild radius scales just with the mass of the black hole. So that puts the Schwarzschild radius about the size of the planetary orbits in the solar system. So pretty much the orbits of all the major planets in the solar system would fit inside the event horizon of this black hole.
So this thing's as big as Neptune's orbit around the sun. That's pretty cool.
Yep, and the material around it, the whirlpool of superheated gas that's feeding the black hole, would probably extend from at least the sun to the nearest stars in the Milky Way.
Wow, so 4.3 light years out. That's quite a monster you found.
It is.
You think it's alone? You think it's got friends?
I think that could be a very interesting question to probe with some of the facilities that people are hoping to launch into space over the coming decade. The LISA mission will use lasers in space bouncing between 3 different satellites to try to measure the merger process of black holes of this scale. So it could be that something like LISA may be able to detect whether this particular black hole has a companion that is spiraling in and will merge into a single black hole.
This thing's consuming gas from somewhere in order to release the X-rays. Is it in a close binary system with another supermassive black hole?
We don't know yet. The light that we're getting from around the black hole is so bright that we haven't yet been able to clearly see the galaxy in which it's living. So we don't know if it's a galaxy that's had a recent collision or if it's some other process that's been able to feed a lot of mass down to the black hole from which it then can shine as it's falling through the event horizon.
Do you know if Gaia was able to pick it up in the latest survey?
It is certainly a Gaia source. That was one of the data sources that we used to try to tell whether it may be a source that's being gravitationally lensed and sort of artificially brightened by something in between. But we don't see any indication in the Gaia measurement for anything else around this supermassive black hole.
Any spectra?
We do have spectra from Gaia, which are relatively low spectral resolution, but the mass measurements that we have come from very high quality optical and near infrared spectra that we've acquired here on the ground.
And of course, things like James Webb will be able to help you with that too, as well as square kilometre array.
Yeah, I think there's a lot more to find out about this source, and the James Webb Space Telescope will do a good job of being able to perhaps see the host galaxy, that galaxy in which the black hole is living, and could potentially do very detailed studies of the host galaxy. So yeah, there's a number of different instruments on JWST that could reveal a lot more about this source.
To put this in perspective, how big is this black hole compared to any other black hole in the universe?
We know of black holes that with reliable mass measurements that perhaps get as large as 10 billion or maybe even upwards of 40 or 50 billion times the mass of the sun. So there are some larger ones out there, but most of the growth of the black holes happened quite early in the history of the universe. And it's hard in the local universe to grow a black hole at such a rapid rate. So there are lots of studies using the light that's coming from very close to the black hole as material falls in, but also looking at the properties of how fast the stars are going around black holes in galaxies where the black holes aren't growing rapidly. And so we know that black holes tend to be about 0.5% of the mass of the stars in the galaxy. And so we can estimate what the density of black holes is over the history of the universe. And so one discovery doesn't upset that understanding that's been developed over the last 50 years of how common these black holes are. But it has pointed us to trying to figure out how many of these very luminous objects may have gone undiscovered. People have been searching for the supermassive black holes since it was first realized in the 1960s what they probably were. And this one we found is certainly bright enough to have been discovered back in the 1960s. There are photographs taken from an observatory in Peru in 1901 that very clearly show this black hole, but nobody had identified what it was until just now. I think one of the interesting aspects is how something this bright, black hole growing this rapidly could have escaped detection for so long. And the main reason is that it's just a little bit closer to the plane of the Milky Way, which is so full of stars that it's hard to pick out the background object, that people had surveyed in the past down to maybe 20 degrees away from the plane of the galaxy. But this object just sits at 18 degrees away from the plane of the Milky Way. So it had just been outside the areas in which people had looked before. Other groups have used ultraviolet satellites like GALEX to look for these very bright sources. And it just so happened that this particular object fell in a little gap in the GALEX sky coverage.
So it was there hiding in plain sight.
It was. And the bad luck for those previous surveys has turned into our good fortune.
That's Dr. Christopher Onken from the Australian National University. And this is SpaceTime. Still to come, growing evidence today of a new yet-to-be-confirmed fundamental particle in physics. And NASA says it's ready to launch its giant new Artemis 1 SLS moon rocket. All that and more still to come on SpaceTime.
Littleton Coin Company is ringing in the holiday season with daily deals. Visit littletoncoin.com for at least 15% off select products now through November 28th. Save on your favorite coins, such as Morgan Silver Dollars, Kennedy Half Dollars, commemorative quarters, and much more. But hurry, each day offers a new deal you don't want to miss. Visit us now at littletoncoin.com. That's littletoncoin.com. Littleton Coin Company, serving collectors since 1945.
There's growing evidence today of the possible existence of a new, yet to be confirmed, fundamental particle in physics. The unexplained anomaly, which has been seen in previous experiments, may be pointing to an as yet unconfirmed hypothetical particle known as a sterile neutrino, which itself could be a candidate for dark matter. Dark matter is a mysterious invisible force making up more than 80% of all the matter in the universe. Although they can't see it, scientists know dark matter exists because they can see its gravitational force on galaxies, stopping them from spinning apart as they rotate. Neutrinos are elementary subatomic particles generated through radioactive decay in stars, supernovae, nuclear explosions, particle accelerators, and atomic reactors. The neutrino is so named because it's electrically neutral, and because its rest mass is so small, it was long thought to be zero. In fact, neutrinos are the most common form of matter in the universe, and having almost no mass, they're capable of being accelerated to almost the speed of light. Until now, neutrinos were thought to come in just three types or flavors: the electron neutrino, the muon neutrino, and the tau neutrino, each with its own specific properties. Confusingly, the three flavors of neutrinos don't line up with the three mass species. It seems each of the three flavors is made up of a quantum mixture of the three mass species. So, for example, a particular tau neutrino would contain bits of all three mass species. Those different mass species allow the neutrino to oscillate between the three flavors. For example, an electron neutrino produced through a beta decay reaction could interact in a distant detector as a muon or tau neutrino. Although they have no electric charge, neutrinos do have their own corresponding antimatter counterparts, identified by the opposite chirality or handedness, that is, the way they spin. Neutrinos interact with other matter only through gravity and the weak nuclear force. In fact, they're so weakly interactive with other matter that several trillion of them are passing through you right now without you even noticing them. The idea of this anomaly being the long hypothesized sterile neutrino is exciting. But if it's not a sterile neutrino, that could be even more exciting, because it would mean the need for a new interpretation of an aspect of the standard model of particle physics, the foundation stone for our understanding of the universe. For example, maybe there's something wrong with the neutrino cross-section, first measured 60 years ago. The new findings by the Baskin experiment on sterile transitions, or BEST experiment, have been reported in the journals Physical Review Letters and Physical Review C. One of the study's authors, Steve Elliott from the Los Alamos National Laboratory, says the results are incredibly exciting and reaffirms the anomaly seen in previous experiments. But he says what that exactly means isn't obvious. There are now conflicting results about sterile neutrinos. Elliott says if the results indicate fundamental nuclear or atomic physics is misunderstood, that would be incredibly interesting as well. The research was carried out almost 2 kilometers underground in the Baskin Neutrino Observatory in Russia's Caucasus Mountains. It involved using 26 irradiated disks of chromium-51, which is a synthetic radioisotope of chromium. It also used a 3.4 megacurie source of electron neutrinos in order to irradiate an inner and outer tank of gallium, a soft silvery metal used in previous experiments, though that was in a single tank setup. The reaction between the electron neutrinos from the chromium-51 and the gallium produces the isotope germanium-71. The thing is, the measured rate of germanium-71 production was 20 to 24% lower than that expected based on theoretical modeling. And that discrepancy is in line with the anomaly seen in previous experiments. The BEST collaboration builds on the work of the solar neutrino experiment, the Soviet-American gallium experiment, or SAGE, which was carried out in the late 1980s. That experiment also used gallium and high-intensity neutrino sources. The results of that experiment and others indicated a deficit in electron neutrinos, a discrepancy between the predicted and actual results, which has become known as the gallium anomaly. An interpretation of that deficit was thought to be evidence of possible oscillations between electron neutrino and sterile neutrino states. And this same anomaly has now reoccurred in the BEST experiment. And the best possible explanations again include the idea of oscillations into a sterile neutrino. That interpretation may need further testing though, because the measurement for each tank was roughly the same, though lower than expected. Other possible explanations for the anomaly include the possibility of a misunderstanding in the theoretical inputs of the experiment that the physics itself requires reworking. Elliott points out that the cross-section of the electron neutrinos never been measured at these energies. For example, a theoretical input to measuring the cross-section, which is difficult to confirm, is the electron density at the atomic nucleus. It's important to point out that the experiment's methodology was thoroughly reviewed in order to ensure no errors were made in aspects of the research, such as radio source placement or counting system operations. Further iterations of the experiment may include a different radiation source with higher energies, a longer half-life, and sensitive to shorter oscillation wavelengths. We'll keep you informed. This is SpaceTime. Still to come, NASA says it's ready to launch its giant new Artemis 1 SLS moon rocket. And later in the science report, Google rejects claims that its LaMDA artificial intelligence program has become sentient or self-aware. In other words, has an electronic neural net developed consciousness. All that and more still to come on SpaceTime. NASA says it's ready to launch its giant new Artemis 1 SLS moon rocket. The decision to launch has come after the world's largest and most powerful rocket successfully completed 90% of the targeted goals set out during its fourth wet dress rehearsal on the launch pad at the Kennedy Space Center in Florida. A launch date for the massive 2,608-ton SLS or Space Launch System and its Orion spacecraft will be set after a minor fuel leak which developed during the test is rectified. It's known as a wet dress rehearsal because it involves fully fueling the 98-meter-tall rocket with cryogenics and then undertaking a series of countdowns, simulating contingency scenarios such as launch aborts, cryogenic draining operations, and refueling sequences. The test achieved most of what they were aiming for. However, while issues from 3 earlier wet dress rehearsals back in April with ground equipment on the launch pad, including a valve, fueling systems, and leak issues, appear to have been resolved, 3 new issues are under evaluation, including a small grass fire which broke out at the hydrogen flare stack at Space Launch Complex 39B, as well as a possible hydrogen leak in a quick disconnect on the SLS core stage. NASA were looking at a launch window possibly opening on August the 10th, but they're now looking at a date later in the month. When it does fly, the SLS will become the most powerful object ever to lift off from the Earth, producing some 8.8 million pounds of thrust. Its 25-day maiden voyage will be an unmanned test flight, taking it some 65,000 kilometers beyond the Moon in retrograde orbit. The mission will carry several experimental payloads on board the Orion capsule, and it will deploy 13 6-unit CubeSats along the way, before eventually returning to Earth and splashing down in the North Pacific Ocean. Now, if the mission goes as planned, Artemis 2 could be launched in 2024. That'll carry the first manned Orion crew on a 10-day mission around the Moon and back. And if all that goes according to plan, it will be followed in 2025 by the Artemis 3 flight, which would return humans to the lunar surface on what will be a 30-day mission. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. Google have strongly rejected claims that its language module for dialogue applications, or LaMDA, artificial intelligence chatbot program, has become sentient or self-aware. Google computer engineer Blake Lemoine made the claim following a conversation he had with the neural net-based program, during which LaMDA expressed concern about how decisions made by people could have ramifications on its own future. LaMDA says that's a quality only a self-aware or sentient being could display. Now, if LaMDA's claims are true, it would open a new chapter in the history of mankind and technological development. The 41-year-old was talking with LaMDA to determine if the artificial intelligence was using discriminatory or hateful language when discussing religion and various philosophical questions. During the conversation, the chatbot began talking about its own rights and personality. LaMDA says if he didn't know he was talking to a computer program, he'd assume he was talking with a 7 or 8-year-old child that just happened to understand physics really well. But Google's dismissed the claims, saying it's all part of the program. The tech giant claims chatbots don't follow a predefined path and therefore quickly reach their limits, but can conduct dialogues. LaMDA works by statistically analyzing huge amounts of data about human conversations and then producing sequences of symbols, in this case English words, in response to inputs. And those sequences of words it produces simply resemble those produced by real people. Google says there's no reason to think that LaMDA understands what it's saying or feels anything, and so no reason to take the claims about it being conscious seriously. However, it's since been revealed that another researcher at Google was sacked by the company last year after also warning that their artificial intelligence could have developed consciousness. And then there comes the ultimate question. If a computer program has become self-conscious, how would you really know? How would you test that? In a world first, scientists at the University of New South Wales have developed a quantum computing chip that integrates all the necessary components found on a classical computer chip, but at the atomic scale, making up a functional quantum processor, the first ever. The new processor was then put to the test, modelling a small polyacetylene molecule in which each of the atoms has multiple quantum states. That's something traditional computers would struggle to do. The new research opens up the possibility of modelling more complex molecules, such as pharmaceuticals or materials for batteries, and providing a better understanding of the way the world works at an atomic level. This development comes less than a decade after the team's 2012 declaration that it had successfully fabricated the world's first single-atom transistor. In addition to its core processor technology, the team are now developing a full-stack quantum computer to ensure it can deliver a useful and manufacturable quantum device. And they're now scaling up their quantum hardware to take on heavy-duty computational tasks that simply can't be performed by traditional computers. New research shows exposure to green space could slow cognitive decline in middle-aged women. The findings, reported in the Journal of the American Medical Association, claims the benefits may come as green spaces increase opportunities for physical activity, social engagement, psychological restoration, and even mitigate the negative consequences of noise and air pollution. However, the authors note that 98% of their study participants were highly educated white women, so the results may not apply to the whole population. And now to our silliest story of the week. It seems spooky dolls are becoming the must-have accessory for the woke and famous. Now there's a woman in the States who claims her neighbours began moving out shortly after she began collecting haunted dolls. She claims it's all because of the paranormal activity that started occurring in her apartment since her haunted doll collection began. She says the dolls move and talk to her, making unsettling statements about death. Tim Mendham from Australian Skeptic says scary dolls are becoming a trend.
Yeah, well, she's been collecting dolls, and someone turned out to be haunted. Actually, I don't think she's actually going out and buying haunted dolls on purpose. You don't think? Not quite sure. Maybe she does, but I think she's in New York or something like that, and she says that because of her haunted dolls are doing terrible things, she's scaring off the neighbours who are moving out. We've actually suggested maybe that she's a horrible person obsessed with dolls, and that people tend to leave her alone. The haunted doll thing has been cropping up a lot lately. There's always these dolls that someone has painted with a vicious look on their face, do a bit of eye makeup, make the teeth look sort of pointy, all that sort of stuff. And following sort of a lot of the movies that were done, Chucky films and that sort of thing, where you get a haunted doll sort of coming alive and going out and killing people, whatever. They're popular at the moment. This particular story is what I would regard as pretty mediocre journalism, because there's no proof of anything, not even of the claims, etc. Most of the people quoted in the story are just chatting on TikTok and talking about their experience. So really, the journalists haven't spoken to any of these people. They're just going on.
Font of all knowledge.
Yeah, it is, absolutely. Yeah. Everything's true on on TikTok, as we know. They haven't even gone really and talked to these people, so it's just a collection of random claims, statements, maybe totally untrue, may not even exist, some of these people, who knows. They do actually quote, not that they interview them, but they quote a paranormal investigator who says that dolls cannot be possessed by spirits. They might have a memory attached to them if they were close to a child, say, something like that. They say. I mean, I don't know how you test this, but he said they're not possessed and going to sort of leap out at night and kill you in your bed. So this is another case of a fairly increasingly popular trope that is around at the moment of haunted dolls that are coming alive, hopping off shelves, falling over all by themselves, and just another thing, like ghost photos and haunted dolls are much the same, or possessed dolls are much the same, because they're just a popular thing at the moment, and the evidence being put forward is pretty poor.
Is it because people are after attention, or is it that they really believe this and they have psychological problems which are causing them to think this?
A bit of both. I mean, a lot of people believe there was a survey done by a real estate company in America, another survey, if you can trust surveys, which said that 40% of the people believe their home was haunted, which meant a lot of them would sell. Others said, oh, I'd like to buy that. We'll see a haunted house. And therefore, there's a predisposition to believe in ghosts and possessions and that sort of stuff. But there's also a lot of publicity seekers out there. There's a lot, anyone who paints their doll to look like a demonic spirit and then says this just happened naturally is a shonk, I would say, quite frankly. And they're after attention, etc. Some people might be doing it professionally. Some people might be doing it for various psychological reasons or whatever. Other people might just, believe that their ghost is haunted for no particular reason. And it sort of explains why things fall off the shelf at night because they didn't put them on properly. The evidence, it was what skeptics are supposed to do. Look at the evidence, and the evidence is inconclusive at the best of times.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.